I was gonna say something funny, but like, let's just do it. All right. So first, pulling up the example that we have, we are now taking finding volume for one shape, and now we're gonna look at some more complicated shapes, break them down into their own individual shapes to find their individual volume, and then add it together. So I know I just said like a lot, and like probably didn't say too much, or maybe it was confusing. So what I'm gonna do is lock this in your brain. There's a cube on top that's 9 by 9 by 9, and then a prism on the bottom, which is 10 by 12 by 3. So here we go. So rather than to like one try and draw this complicated shape, I would rather just draw, rather than trying to draw this complicated shape, I would rather just draw the, okay. All right, so I just made two like little makeshift shapes. I separated them automatically so that my brain could understand that I need to find the volume of two different shapes and then add them together. I'm gonna start with the cube up top. The cube up top has the following dimensions: 9 feet wide, 9 feet tall, and 9 feet high. So, or 9 feet long and 9 feet high. We're gonna do 9 times 9 times 9. 9 times 9 is 81. I'm gonna bring down that last 9, and then 81 times 9 is 729. And that's cubic feet. 729 cubic feet. And then we're going to do the same thing for the shape on the bottom. So I noticed that it is 12 feet long by 10 feet wide by 3 feet high. And then 12 times 10 is 120 times 3. And then 3 times 12 is 36. So 120 times 3 is 360. And again, that is cubic feet. The only step that people need to make sure that they are doing for this lesson is combining them in the end, like finding the volume of all of the shapes that you have and then adding them together in the end, which would be 729 plus 360. I know I'm got like the old school math setup going on right now, but it's cool because y'all rock with it. And when we add those together, we get 1,089 or 1,089 cubic feet. And that's how you would do that first problem. Lock it in your brain or pause the video or do whatever it is that you need to do. I'm going to set up for the next one and the next 5, 4, 3. Man, listen, I'm doing no countdowns. I'll just pause the video. All right, so looking at example 2, I'm going to zoom in so that this is the only thing on your screen when we're looking at this. So we need to find the volume of this irregular solid. I know this is a problem that we kind of did before, and I like showed you on the whiteboard how we could like break this up. I'm going to actually create 2 different shapes and label them both so that you guys can see like what I mean by breaking this up so that you can find the volume of 2 different shapes and then add them together. So here we have a smaller box shape right here, and then a larger rectangular prism in the back. We're gonna break these up like so. Okay, and you guys get to see some of my awesome square making abilities. Hang on. Okay, there we go. So first, I'm gonna get rid of all of this and all of that. Come on, come on, don't make my life hard. I'm gonna get rid of all of this work. Okay, so I already went ahead and I just broke up the two shapes so that you can kind of see what I was talking about. There's that rectangular prism that's in the back. That's the shape that's up here. And then we have the cube that was in the front, which has the dimensions 5 by 5 by 5. So you're gonna have to like pay attention and like really like label this irregular shape to make sure that your dimensions are right. But when you do that, everything else after that is like a total breeze. So we're gonna first find the volume for shape one, the rectangular prism. It is 5 centimeters long, 10 centimeters wide, and 5 centimeters high. 5 times 10 is 50. Bring down the times 5. And then 5 times 5 is 25. So 50 times 5 is 250 cubic centimeters. Now for the cube, that's a lot easier. 5 times 5 times 5. Oh, geez. And then 5 times 5 is 25. Bring down that last times 20, times 5. And then 25 times 5 is 125. The last step, the step that everybody has to promise to do, is to add them together. That is the last step. You won't get half credit if you don't do this. So 125 plus 250 equals 375 cubic centimeters. That would be the final answer. I wouldn't accept 250, 125, or anything that isn't 375. Yeah, so take a minute to like lock this in your brain. Once you get good with breaking up the shapes and like that makes sense to you, then everything else is just the same as it was yesterday, but just with that added step of adding them all together. How do you feel? I hope you guys feel good about it. I got one more to do, and then we'll leave you to do it for yourself. Okay, so let's go back to the example first before I show you like how I decompose this. So what we have is something that it isn't labeled like the first two examples, but we can still determine the dimensions because what we're looking at are unit blocks. So basically what each segment of this line represents is 1 unit. So this would be, if we're going across the top of this would be 1, 2, 3 units wide. And if we were to think about the length, it would be 1, 2, 3 units long. And if we were to look at the height, it would be 1, 2 units high. So when we're thinking about that, we can like use the unit blocks to label our shape after we decompose it. So that looks like this for us. We have each of these shapes has the same height. Each of these shapes are 2 units high. That one's 2 units high. This is supposed to represent the space in the middle, and this is supposed to represent the space on the right. So the top is the left side, the middle one is the middle side, and then this one to the right is the right side. I mean, this one at the bottom is the right side. They were all 2 units high. The other thing that I noticed is that they are all 1 unit wide. And the major difference is how long they are. So the left and the right side are both 3 units long, while the middle side is only 1 unit long. So these are what the dimensions kind of end up being for each of these. The left and the right hand side have identical dimensions. Length of 3, width of 1, height of 2, 3, width of 1, height of 2, 3, 1, 2. And then this one has a dimensions of 1 unit wide, 1 unit long, and 2 units high. And so the major difference between that and what we're doing here is that one, we're talking about units, and then we need to add we need to add a third shape for this one. Clear off my workspace. Almost done. Okay, so here we go. 3 shapes. Let's do shape 1. Shape 1 has a length of 3. times a width of 1 times a height of 2. 3 times 1 is 3. Bring down the times 2. 3 times 2 is 6 cubic units. All right, now that middle shape has a length of 1, a width of 1, a height of 2. 1 times 1 is 1. Bring down the times 2. 1 times 2 is 2. The middle shape is 2 cubic units. And then we could honestly probably just copy and paste the stuff from shape 3 because we figured it out in shape 1 and those are identical. So we're looking at 6 plus 2 plus 6. 6 plus 6 is 12 plus 2 is 14. So we could just do 6. 6 plus 2 plus 6 equals 14 units to the third power. And this is how you would solve a problem as such. Break it up into your shapes, and then you just solve for each of those shapes individually, add them all together at the end, and do not forget to add them all together at the end. That's how you solve that. If you need help, you can go back to the lessons from the first week, which the first week of 3D shapes, or you can just watch this video a million times. I know you love my face. Do well, make me proud. Continue to put up that work and be great. You guys are legendary. All right.